Hi, welcome to our last lesson in Chapter 5. Today we're going to be looking at techniques to solve trigonometric equations. And the good news is they're equations just like all the equations you've solved forever. The biggest difference is that the trig functions are periodic. So lots of trig equations will have more than one answer or multiple solutions. That just means there are, like if we're looking for the place where the sine is 1/2 in the coordinate plane, or if we think about the angle whose sine is 1/2, we have one of them here at 30 degrees. Sine is also positive here. So since we have that periodic motion, that repetition, twice within one rotation you'll get an angle whose sine is 1/2, but if you consider all the rotations, trig equations can have more than one solution. If, however, we restrict the variable to certain quadrants or certain values, certain quadrants I'm going to call it, we can limit the number of solutions, and we'll call those limited solutions principal values. Some of you will remember, many of you will, that when we were graphing the trig functions, we introduced the idea of the principal quadrants for sine and tangent. Those are in Q1 and Q4, and the idea there is you'll get a whole range from -1 to +1 of both sine and tangent in those two quadrants. For cosine, the principal values are in quadrants 1 and 2. And again, in cosine, in terms of x, if you go through quadrants 1 and 2, you will have gotten the full value, the full range of numbers -1 to 1. So what I've done here is make a picture of a table that you may have put on your unit circle. If you didn't put it on your unit circle, then I'm going to encourage you strongly to get it there today, because we're going to want to be able to tell quickly which angles, say, have a sine of 1/2. And when we look on here, we'll see that it's 30 degrees, or it could be -30 degrees, right? This table is going to be a very useful tool for you today, so if you haven't got it, I'm going to suggest that you copy it down. Let's begin by solving equations using some algebra techniques. Okay? If our job is to isolate x, then we got to think about the things that have been done to it. Somebody's added 1, somebody's multiplied by 2, and they multiplied the sine by 2. So we've got to undo that stuff. Start, of course, by subtracting the 1. So 2 times the sine of x will equal -1. Divide by 2, the sine of x will be -1/2, and then to find x we need to know the angle whose sine, so this is sine inverse, the angle whose sine is -1/2. Now that can be put into your calculator, but don't get me wrong, I'm going to ask you to use your head today as opposed to your calculator, at least until the end. And if we look at that handy dandy table, sine is 1/2 at intervals of 30 degrees or pi/6. We need it to be negative, so that means we're in the 4th quadrant, and the angle there is -30 degrees or -pi/6, depending on what the problem is looking for, whether it wants the radian or the degree measure. I'm going to leave this table sitting out here for just a little bit, and we'll see it pop up in other locations as well. We're going to solve the equation for values that are within the first full rotation, so within the first 2 pi radians, and this one specifically is asking about radians. So you have a squared there, folks. That's looking quadratic, and I think the only way to get to that is to move all this stuff to the other side. So let's think 2 sine squared x minus 5 sine x minus 3 equals 0. And now we're thinking about factoring, because that's a good algebraic technique here, or you could use the quadratic formula with the numbers, but I'm going to say I think this one factors. So let's do our x box. We have to multiply to make 2 times negative 3, which is negative 6. We have to add to make negative 5. And I think that you'll agree, negative 6 and 1 are our solutions. Now we put that into the box, which we need 2 sine squared x and negative 3. Those are the components that go in there. And on the other diagonal, negative 6, then these will be sine x and 1 sine x. And then you think about greatest common factor, and here it would be 2 sine x. That would make this one just be sine x. To get that negative 6, you have to multiply by 3. To get this 1, you have to multiply by plus 1. So the factored form of this quadratic is 2 sine x plus 1 times sine x minus 3 equals 0. When you set each parenthesis equal to 0, from this first parenthesis, you would have to, so now we're solving. 2 sine x plus 1 equals 0, and that can only happen when the sine of x is negative 1/2. That's good, because we already know about that. The other parenthesis says the sine of x minus 3 equals 0, and that would say sine of some angle is equal to 3. Folks, that's not possible. Sine can't go to 3. Okay? It's not possible. There is no solution there, or that solution is extraneous is the better way to say it. So our answer has to come totally from here, and since we want to be in the whole full circle, 0 to 2 pi, we know that we get it here at negative 30 degrees. Sine is also negative 1/2 here. So we have to talk about both of those angles. X is either negative pi sixth or let's see, that would be 6 pi sixths, and we got to go one more, so 7 pi sixths. You could also express this angle as 11 pi over 6. The positive, I'm not going to change that now. However, you should be aware, especially if you're looking in the back of the book at answers to equations, they may have taken the negative angle and made it positive, so don't forget about that. All right, let's go on. Okay, here we're solving in degrees, which is good for some of us, and it says we're going to be using identities. So I'm going to think that we need to look at an identity for cosine of 2x, and I know that there's one that has sine squared only in it, so I got to look that up. I don't have those memorized. Oh yeah, we can replace cosine of 2x with this 1 minus 2 sine squared x. And that just is using the identity for cosine of twice an angle. Now equals sine squared x minus 2. And now we're on our way. We just got to use our algebra. Let's see. Negative 2 sine squared x's. And we want to move this over there and that there. So we're going to add 2, and we are going to add 2 sine squared x. So let's see. We would get 3 equals 3 sine squared x divided by 3. 1 is the same thing as sine squared x. And if you take the square root of both sides, which would be the last step of algebra, then taking the square root of both sides, sine of x would either equal positive 1 or negative 1. I don't think our table is going to help us because we didn't have the quadrantal angles on there. That is, we didn't have the sine and cosine here. But we're solving within 360 degrees, and we want the place where sine is 1. Sine goes with y, and that's going to happen right up here at 90 degrees. When sine is negative 1, that's down here at 270. So our x's are 90 and 270 degrees. Those are the two places in the first full circle that have a sign of 1 and -1. All right, let's look at the third example. It looks like this is another quadratic here. We're solving this time for all real values of x, and that means that we're going to have to include some like pi n thing with our answer. But let's see if we can't factor that. Oh yeah, I think you can do that probably just by looking. The tangent of x plus 1 times itself is the way that that would factor. And if you're not trusting me, multiply it back in your head and you'll see tangent squared. There's a tan x, the outsides, the insides are a tan x, and the lasts are 1. So we are looking for the spot where tangent of x plus 1 equals 0. And if you solve that, tangent of x equals -1. And that would mean that our x is the tangent inverse of -1. Now I want to call this up here because I seem to recall a tangent of 1 in here. Oh yeah, 45 degrees, right? It says we're doing it for all real values, so I guess we can talk degrees if we want. But we have to have the tangent be -1. So I know that that happens. Now I'm going to get this out of the way. It's a 45 degree is what we're looking for. And I'm going to come back up here to my coordinate grid. We need the angle whose tangent is -1. Now I know it's one of the 45s, but it has to be the -1. So there's one place where that happens. And the only other place where tangent is negative is up here in quadrant 2. So those solutions will happen at -45 degrees and every 2 pi after that. Or it's almost easier to say it in radians. -pi4 plus 2 pi n, where n is an integer, so a full turn after that. And at, let's see, that's pi4, 3 pi4 plus 2 pi n, every full turn after that. If you wanted to talk about them in degrees, you certainly could, folks. That -45 degrees plus 360 n, as well as this one is 135 in degrees plus 360 n. Oh, it says use your calculator. Cool, let me get mine up. All right, I think I'm ready to use my calculator. It says that we should solve it for x between 0 and 2 pi. So that's within the first 360 degrees, or the first full turn. Let's go to our y equals. I'll tell you what, I want to just check my mode because I'm afraid I'm not. Get myself in radians since this calls for radian answers. And let's go to the y equals and let's put this guy in there. We want the sine of x divided by 3. So sine of x divided by 3. But what we want to know about is when that's equal to 1/2. So on y2, I'm going to put in, just show me, the horizontal line where y is 1/2. As far as a window, we need to be between 0 and 2 pi in x's. So 0, 2 pi, and I'll just tell it to go by pi halves or pi quarters. It doesn't really matter about the scale, I don't think, but I'll make it go by pi4. As far as y's go, we're talking about a sine equation here, so -1 is as low as it can go. I'm going to set mine for -1.5 just so we got some space under there, and 1.5, and going by 0.5s would be fine. And let's take a look at our, oh, there's our little wave. Okay. Between 0 and 2 pi, there's only one place where those are identical, and I hope that you'll remember our handy-dandy second trace menu, which allows us to find the intersection. So second trace and 5, and We want to be close to this intersection. You don't have to be right on it, but you have to be closer to this one than you are to any other. So then, and once you're close, it's enter, enter, enter. And it's telling us that y is 1/2 at x of 1.57. Now, ladies and gentlemen, I think I have some prior knowledge about this. So our equation is, or our solution is, x is around 1.57, but I just have a sneaking suspicion that that's a pi half. So I'm going to go back to my working screen and I want to verify. I think that is pi half. So second pi divided by 2. Yep, it is. So we can call it around 1.57, or pi halves would be the more precise answer. As far as writing down a procedure for yourself, you put the trig equation, or the trig part of the equation, trig part in y1. You put the number part in y2, and then it's second trace and intersect, and then you hit enter 3 times. So that's nice to know that we've got that as a backup for ourselves. All right, that's the end of our lesson today. I hope that you'll get out there and do that trig quickly as possible, and we'll see you in school.